But the first time I heard DePIN, I'm like, what is this? And actually diving in, it's actually extremely exciting stuff in general. Every time I hear about a use case that people are diving into technically, it's always really, really cool to hear.
I think it's one of the reasons I found like what you guys are doing at NovaNet. So, at EV3 we're pretty big owners in a lot of DePIN tokens, and I've been a part of these communities, and we've seen a lot of different attack vectors on, just seeing the economics of these networks leak out to people who are scammers who are finding ways to use the network in non actually productive ways.
Yeah, I mean, especially this cycle, the proliferation of just so many different projects launching in different kind of like real world sectors, whether it's energy or telecom or anything else, has just been really, really cool to see.
I think that bringing ZK into the law and regulation has a lot of potential, untapped, of course, so far.
Thank you guys very much for joining. Really appreciate it. Sal kind of brought this episode to us in terms of knowing you guys and being excited about having you on. And I just did some research beforehand, obviously, to get up to speed. But yeah, really excited for this conversation. Houman, wanted to start with you. I was looking at your Twitter, and it seems like you've tweeted a lot of cool, kind of interesting stuff, especially about the yin and yang between zero knowledge proofs and blockchains. So just curious if you could kind of expand a bit on that. Like, how are the two technologies distinct, yet like how do they also work together? Would love your thoughts on that.
Yeah, absolutely. Thanks for having us on here. I think that now that ZKPs have developed so much, we can take a step back and think that, hey, there are two ways to verify transactions or maybe compute more generally, state transitions in the case of blockchain. And one is, of course, blockchain consensus mechanisms, which rely on re-executing among the nodes, basically the same transactions to confirm that they're accurate and build that chain blocks, versus validating or verifying transactions using zero knowledge proofs. And obviously the entire L2 industry is based upon the fact that some things are more optimally verified off-chain with ZKPs, and then are proven off-chain, verified, and then brought back onto the major primary L1. And so in that way, there is a competitive dynamic between, should we verify with on-chain, with blockchain consensus and re-execution, or should we verify with ZKPs, which kind of by definition are off-chain? That's only possible, again, because the cost of ZKPs that Wyatt will tell all you about why become so much more affordable and fast and everything else. But I don't think everything should be ZKP. I think maybe much closer world of the ZKP endgame, where ZKP does run a lot more compute and do a lot more things, let's say, than currently is the case. But I still think there's a great role for blockchain, and you'll see that embodied in NovaNet, which is, first of all, being a public transaction record for proof verifications, like prove it wherever, but come back to Ethereum and verify it, or whatever chain. And also to provide for the incentive mechanisms, the tokens and the tokenomics and the orchestration, so that at the very least, blockchain can provide those roles as well.
100%. Yeah, and it feels like zero knowledge proofs have been more and more in the zeitgeist of just like crypto kind of conversation and narrative, especially this cycle. So I think it's a pretty like high level kind of basic question, but just in either of your opinions, like why are ZKPs specifically valuable to the world, different use cases, especially in the context of like the crypto industry and maybe some DePIN/crypto use cases?
Cool. I think I'll jump on that one. Just a brief history of ZK and how it became more performant. The first thing that we were doing is actually making the verifiers really performant. And that's what we see a lot with like Groth 16, getting these verifiers small enough to get onto blockchains in the first place. But more recently, people have been looking at like prover speeds and prover efficiency. So the core use case that we actually see, or that's been spoken a lot, are ZKP for scalability. Like how do we scale Ethereum, ZK EVM, ZK rollups, all these things. But ZK actually has a longer history, and it's more about privacy and verifiable compute more generally. It's not just about scalability. You go to like a ZKP event, most people were talking about like ZK VMs that do Ethereum scaling, but it's really used for these two other things that are very important for a bunch of different use cases, local verifiable compute, and also this privacy type use case. So in the context of like DePIN, if you have something that's very portable, like a ZK VM that's very memory efficient, you can actually verify compute on a bunch of different types of devices. So in contrast, once again, with the scalability startups, you don't need specialized hardware in this case to run proofs as fast as possible. You can actually let it run on these local devices, maybe smaller proof sizes, and you guys get privacy with that as well. So maybe you don't want to expose your specific location. For example, like there's DePIN that have a composability layer that's like proof of location. You can actually prove your location, like, hey, I'm in the US, without exposing like the exact city, with using ZKP with other facets of DePIN.
Gotcha. Yeah, no, that makes a lot of sense. Now I think kind of like specifically on you all and NovaNet, just what are each of your backgrounds and how did you find each other? How did you get started building NovaNet?
Yeah, maybe I'll go first. My background is in law and academia, but also tech startups, blockchain focused startups. And then also, at least at one point, I was very much into building without code and really empowering entrepreneurs to take kind of the next level of abstraction of software development tools and build without code. And that was kind of how Wyatt and myself met.
Yeah, I'm a super technical person. I've been working for venture capital as one of my very first technical jobs, helping startups basically scale up MVPs. So very like from 0 to like 10 people type roles, and also private equity, which is the end of the spectrum, which is like big companies, and we bought the company and then we had to run it. So I've been doing those for quite a long time. I actually ran a few of my own projects from scratch as well. There was one in 2019 that was like a skeuomorphic office space, which is like a virtual room. We have meetings like what we're doing right now, but you have like proximity. So the closer you get, the louder you hear someone, the further away you get, you don't hear them. In 2019, people were like, that's stupid. Why would anyone want to use anything like that? But then the pandemic happened, and it was just like good timing for that type of product. And it was the most used lecture hall for universities in Japan at the time when I was living in Japan. That was acquired summer 2021 by a Swedish gamification company. I think they made it into like kind of a gamified version of the same thing. But from that, like coming back to Web3, like I've known about Web3 for a very long time. My brother was using Bitcoin and mining Bitcoin when Satoshi was still on the forums. So I've known about it for a long time, maybe in not the greatest light because he was using it for like Silk Road and those type of things. But yeah, I knew about it for a long time, and jumping back like into Web3, it was difficult for me as a technical person. And ICME was really about like, hey, let's build no-code tooling for NFTs and also just roll-ups and things like that. But from there, we had customers actually say, hey, we want to use zero-knowledge proofs for X, Y, Z. And we tried to do a few manually. This is like 2021. We're using something called Circom. And it was super like tedious and not scalable whatsoever. And that's when I think we pivoted 100% to NovaNet, saying, hey, we need something that's super portable, super easy to use, and very basically an incentive layer to basically build upon a composable layer of ZK proofs and ZK technology that is very like research driven. And that's really where the idea of NovaNet came from, was this like no code, low code, going to ZK, and then finally making it portable and scalable version of zero knowledge proofs.
Yeah, coming from a legal background, ZKPs really appealed to me too because of the verifiability component. Like here's a technology that maybe is associated with scaling Ethereum, or of course smart contract privacy and payment privacy, as some of the original or some of the path-breaking projects like Zcash really focus on that aspect of it, which is one of ours as well, but also just like the underlying verifiability of things. And the law cares so much about proving things and whether they happened or not. And did you sign the contract? Was someone at the place at a certain time and all that? So ZKPs had an appeal to me. Also, coming from, I guess, a legal background where most of my career focused on law, testifying before the government, including on Bitcoin derivatives and financial markets and regulation. So I think ZKP has a really exciting application for all of those areas and use cases where verifiability matters, but we still want some measure of privacy and decentralization and all that good stuff that's now enabled by what Wyatt will discuss, really exciting developments happening in academia and research on the ZK side.
Your point on verifiability is really interesting. I think it's one of the reasons I found like what you guys are doing at NovaNet. So, at EV3, we're pretty big owners in a lot of DePIN tokens, and I've been a part of these communities, and we've seen a lot of different attack vectors on, just seeing the economics of these networks leak out to people who are scammers, who are finding ways to use the network in non actually productive ways. And that's led us towards thinking a lot more deeply around DePIN consensus mechanisms and how you can like actually verify some of these tools. I'm curious from your guys' perspective, like why focus on DePIN at all? If I'm a DePIN entrepreneur sitting here and thinking about starting a protocol or have an early stage protocol, like why and how should I think about using some sort of like ZK powered proofs in my consensus mechanisms?
Yeah, I think mathematical proof is quite a powerful thing. It is basically, you can't fake it. So once you have a mathematical zero knowledge proof, it's good to go forever. Even if in the future someone makes a cool post-quantum computer, it doesn't really matter in the past. When you make a proof, it's pretty good to go. And it's much better than these other type of verification methods that might have to have something recomputed over and over again for it to be verified correctly. In terms of timing, like the reason why I think it's important for DePIN projects now to do this and get into zero knowledge proofs, or at least use them in some fashion, is that it's becoming memory efficient enough to where you can use it on a bunch of different devices. So these could be local devices, broadcast devices, whatever it might be, and then run these things in many different locations. So this is way out of the context of scaling Ethereum, but really with memory efficient ZKP, you can prove on many different types of devices. And with that, you get really cool composability. So say your company makes like proof of bandwidth, a proof of location, you can actually make those primitives available to every other DePIN project. And basically, if we all use the same mathematical proofs, you built one thing once and you can reuse it across these projects. And that's why I think it's interesting about the work we do with our partners that are in the DePIN space with NovaNet. We say, hey, these things are fast now. Like they're fast for a lot of different use cases, depending on the proof size. There's some things they're not fast for a lot of things they are. And also they're super portable and we can build together kind of this composable layer for a bunch of DePIN projects to use.
Yeah, I think as a blockchain entrepreneur, at least some important things you can take for granted that they will be verifiable if it happens on chain. If it's on chain, it's true, and we kind of don't need to second guess that. But for a DePIN, where a lot of the action takes place off chain, you do have that verification problem, especially because you're throwing decentralization into the mix. And so looking for verifiability solutions to build into your DePIN network, your protocol, and have them have the same, if not better, guarantees than blockchain-based, on-chain-based verification, I think is very important. And as Wyatt was mentioning, now is the time, ZKP is having a moment, and now is the time to kind of roll out these verification products, if you will, that can be applied widely, I think, across different types of DePIN projects with different types of problems, yet share a common core of challenges when it comes to verifying things that need to be true, and from top to bottom, really, right? Like who's a member of the network? Are they real or not? We've seen this recently with some fairly public mistakes I think projects have been making. That's fine, that's part of the growing pains of the industry. And fortunately, we're very excited by DePIN for the reasons I think most people are. And we have what we think is a really cool solution.
100%. Curious to ask you guys specifically about like the proof of location piece, for example, like there's some folks working on, I think, like less privacy centric versions of this, or versions where, you can just you can have a node network, you can secure it with like staked ETH or staked SOL, or like borrow security from some other ecosystem and just send multiple pings to a device. And if you get a ping sooner than is physically possible with the speed of light, then somebody gets slashed and you prove a location for them with no sort of like ZK element. Curious, when you guys think about proof of location with that ZK part, what is the incremental, what are the use cases that privacy adds, or why do you think about the the incremental cost that you're incurring by sort of running this computation on the edge device?
Yeah, I think the context of restaking and AVSs in general is kind of new. So still the security risks there are not completely well known. We might see some things that come up in the future. You say the same thing with ZKP as well, but it's been around quite longer. But for securing things with restaking and stuff like that, it's still relatively new. For running the device or running on your local device, what I think is important about that is if you can create a proof one time, it's verifiable by anyone, anywhere in a succinct fashion. That's why they call them ZK snarks. It's very cheap to do the verification. It might be a little bit harder to do the proof itself. And that allows you to have whatever device, whatever blockchain you want as the end to basically verify it. It could be on Ethereum or Solana or whatever it might be. You don't really have a lock-in for that. Houman, did you have a comment?
Yeah, not too much in addition, but yeah, I mean, one way to kind of guarantee the accuracy of your location is to be sure to generate a proof that you're not essentially trying to fake your location or otherwise take advantage of a vulnerability in the network. And I think that ZKPs, especially ones that can run on the devices themselves, are really valuable to the industry, to the network. And that's one thing that we're really excited about and really pushing forward are these proof systems that can run on edge devices or constrained devices, which unlocks a whole new level of authentication and verifiability, and I think just trust in these networks.
And also privacy is one thing that I would like to point out from what he just said. If it doesn't run on your local device, it's not private. So the moment you give your data to a third party to do whatever they want with it, they have your data. So if you really want true like privacy preserving things, you need to run these ZKP locally, and the proof of location is just one good example where you can run the proof of location locally and say, hey, I'm only going to expose my state, or I'm only going to expose this one specific thing, and keep everything else hidden, essentially. And zero knowledge proof would say, hey, he ran his model correctly or his program correctly. He only wants to expose this one thing, and that's all it exposes. And also the cryptographic proof that says, hey, you ran it correctly. So local proving is super important for privacy.
You guys have done some like a lot of academic research. I think it's finally coming to fruition in terms of the performance advantages, in terms of folding schemes and the optimizations around just the actual architecture of your guys' proofs. Can you guys maybe talk for the DePIN entrepreneurs who like know some cryptography or who are building on these blockchains but don't know maybe what a folding scheme is? Like I didn't when I first met you guys. Like what is it? What are the benefits of it? And just like how is your guys' architecture differentiated?
Yeah, there's been a few iterations of folding schemes, even maybe since the last time we spoke. So it's a very like a progressive field in, I would say, cryptography that is doing these iterations of folding, which is basically a primitive that came out, I think, 2008 by a guy named Valiant. It was like, hey, can we take a proof and put it inside another proof and another proof and another proof and keep doing that forever and have something called incremental verifiable computation. And what that allows you to do is have a final thing that's the size of the first thing. So you can have basically one thing that's 100 bits long and keep doing it over and over again. And at the very end state, you might have done tons of computation, but at the end it's still 100 bits long for the final proof or for the final computation. So incremental verifiable computation is super cool for the memory efficiency. But then in, I would say 2021 or 22, there's another researcher from Microsoft, Saran Sethi, who made this very cool new folding scheme that had the benefit of having not a snark and a snark and a snark, or not a ZKP and a ZKP and a ZKP, but a much lighter iteration version, which is basically the bare minimum thing you have to do is 2 commitments in each step, which is extremely mathematically light. So it's not taking this huge, heavy ZKP thing and compiling it over and over again. It's actually just doing very, very fast iterations with 2 commitments. And with that, you have a very cool thing for memory efficiency, but also something that's extraordinarily fast. From there was actually something called Supernova, which is a paper from the same author that came out a year later, the same authors. And it had something called non-uniform incremental verifiable computation. And that's what we use in our ZKVM and NovaNet in general. And the reason why that's cool is because you don't need to have the one initial circuit be uniform. So I mentioned that thing that was maybe 100 bits in length. You can only use one. Right, is compressing 1 and 1 and 1 and 1. So you have to use the same computation at each step with IBC, but with non-uniform IBC, you can actually use many different computations. So it could be one program that does one thing specifically, or another program, and you only pick a la carte the things that you want to use. So it's cool for if in NovaNet, say there's 100 different people who want to use NovaNet for 100 different things, and they all have their own circuits. They can actually all kind of collaborate together to have really fast proofs and kind of specialize in their own field. Or for the ZKVM aspect, like say your project only uses like 4 opcodes. You don't want to pay for the other 500 opcodes that might be in your ZKVM. You only want to pay for those 4. So it's very, very cool for that use case where you can have a la carte pick what you want to use in terms of your proving system.
First innovation is doing that nested ZK proofs. Second innovation, like making that sort of like nesting process much simpler. So there's only 2 steps in each of them. And then what you guys are doing around non-uniform, basically making them composable so that each layer of like concentricity is different or can be different and can combine with each other. Is that roughly right?
Absolutely. That's a really good way to summarize. Didn't know how far we're going to get into the weeds on that or not. So I kind of made it like mid-level. That's exactly right.
Awesome. Yeah, it's super interesting.
Yeah. Thinking about, I know you guys you're pre-launch in terms of mainnet and token, right? So thinking about like the go-to-market, and I know there's kind of other sectors, I guess, within or without crypto that you will want to take your technology to, but specifically about the go-to-market for DePIN projects, like what's kind of going to be the high-level sales pitch to a DePIN founder? What are the benefits? Obviously, there's some additional costs to having this level of verifiability and kind of like trustless verifiability. So yeah, just curious kind of like what the go-to-market and sales pitch is to a DePIN founder that you want to bring your technology to.
Yeah, I think the bottom-up approach, we actually have 2 different approaches that we like to pitch. The bottom-up is basically aggregating the proofs together and posting the sheep on chain. So you might have like 1,000 different devices, and each one post is going to be super expensive for you to get it onto any like blockchain for anyone to verify. But what you can do with NovaNet is actually aggregate all those together and post onto one chain. And it works as an orchestration layer to where you don't really need to deal with all the details of like where do these proofs go, who's doing the proving, who's going to control the privacy, and who's going to control the aggregation. So it's just a very simplified, I would say, peer-to-peer layer that does all this stuff for you and incentivizes people doing it. There are some use cases where you do actually need like specialized provers to do things. And with the NovaNet layer, you can actually get faster proofs and cheaper proofs by using specialized provers. It kind of works like an Uber where you can hire an Uber Black if you want it. If you don't want it, you don't have to use it. But with the network, you get very good and very fast and potentially cheaper proofs than anywhere else by using the network. From the top-down perspective is when you have like a really big problem and you want to break it up and parallelize it across a bunch of different machines. And in some use cases, you do actually need that. Like if it's a gigantic computation, you're not going to try to run it on a local device. And for that, once again, like NovaNet's a really good option to use because you can actually break up the proof into many different pieces and run it in parallel. And that does orders of magnitudes in terms of speed for these really big problems. But really like our bread and butter right now is just the bottom-up type approach where we have things running on a bunch of devices and you would like to aggregate it or make it faster or make it cheaper.
Gotcha. And so I guess the core ZK use case within DePIN is probably just like around real world verification, right? Like what is actually happening on these devices with their data. And that has kind of like sub use cases of like anti-gaming, maybe like anti-Sybil type, use cases as well. But so the end state, you think maybe in 5 years, right, when NovaNet takes off and DePIN takes off as well, as like on most DePIN devices, like on the edge device itself, there's NovaNet running basically, and so you can verify things locally.
Yeah, there'll be completely peer-to-peer. So absolutely, like the devices themselves will be connected to the network, and they'll be able to run the version of the proofs that they want. The thing that they can benefit from, though, is if they are super constrained, they still have privacy proofs, and they can give some of the harder proving to other devices if they need that. So it's kind of the mix of those two things with proof of cooperation that makes it super useful for a bunch of different use cases.
Yeah, I think what we're doing is exciting for DePIN because it very much is being built in parallel with the DePIN philosophy of decentralization, local nodes, powering a network, providing services, and we are not a centralized ZKP as a service. We're not a new one that you need to buy into its token and that type of thing. We really are, the end game will be running alongside the network itself, inside the network, if you will. And that's what's really exciting in terms of the vision we are pushing for DePIN.
For sure. And I mean, I think the real world verification problem still hasn't been fully solved in DePIN. I think you guys definitely present a pretty compelling potential solution for that. But some other solutions I've heard of that people are playing around with are like trusted execution environments on the device itself or secure elements within those devices. So, maybe just like what do you all think about those approaches, kind of strengths, weaknesses versus ZKPs running locally on edge devices?
Different trust assumptions. You still need to trust like the hardware creators to have done the trusted execution environment correctly. But we have some partners that actually talk about soft enclaves as well, which is basically like a software version of doing the same thing. And then you would use that with ZKPs to kind of have the best of both worlds. So I think there's some level where they can actually cooperate together and work well together. And there's some areas where it's just impossible. Like if it's a user's phone or some other device like that, sometimes you just can't have a trusted execution environment. But you could have the potential to have like a software version of it running, and then you could verify certain facts about it. So I think whatever's cheapest will probably eventually end up winning, like whatever's most practical that already works on most devices. And I think ZKP is the way we're going, and the incentive layer there of like making faster and more portable and better proving schemes will be a very attractive option for the next 5 years for sure, for projects looking for verification in the local scale or more broadly.
I just want to add that whether it's trusted execution environments, secure enclaves, even fully homomorphic encryption, all of which have really high potential in terms of independent technologies, it's still always helpful to have a proof that those things are running correctly. So you don't necessarily need to trust a particular setup or a particular hardware manufacturer or a particular encryption from running correctly. So ZK FHE is better than just FHE alone. And we're really excited about adding a ZK layer to all these other exciting technologies that in most ways are complementary.
Makes sense, yeah. And I agree. I think over time, like we ideally we have this, this efficiency curve of different types of trade-offs that we can have between privacy and security and trust assumptions and price. And entrepreneurs can go and build on top of them, including in DePIN and many other industries. The place I want to go to next, guys, is to understand from you guys if there's anything you can tell us more about like NovaNet's own crypto plans. Like, should we think about it like going to be a blockchain or a token network over time? Like, how do you see it evolving?
Yeah, I hate to say L2 because that like infers like scalability, like ZK L2s and things like that. It has a very nimble smart contract that works on Ethereum for the orchestration portion. This is like what controls the token. But really, as a user, you can decide where you want the proof to be posted in the end. You can say, hey, post it to my Web2 server, or hey, post it to XYZ blockchain. So there's no verifier lock-in. You can have the network push to wherever you want it to. The network itself is completely peer-to-peer. It's based off something called libp2p, which is open source from Filecoin. So it's like a really well-known, really well built out peer-to-peer library. You can use that on your personal network. You can use that on your own DePIN network. You can use it for Web2. You can use it for Web3. So that portion is really open. I would say the L1, the nimble orchestration layer, allows for the incentive layer that is very important. Like I mentioned at the early in the talk, we were talking about like if you made like a composable proof of location or a composable proof of bandwidth, you can actually expose that to NovaNet and other people can use it directly. So we really want to incentivize these things and have orchestration where newer proving schemes might come up or newer things for DePIN might come up, newer things for ZKML might even come up. And you're able to get the fastest version of those in an incentivized way on NovaNet. So you might be a researcher and do like a ZKML paper, which is like machine learning for zero knowledge proofs, and have this really cool new proving scheme and get paid for it essentially and get incentivized for using it and building it out. And I think it will be the same with DePIN projects. We have sometimes very specific use cases that are actually more generalizable. So that whole area of thinking about like how do we incentivize ZKP in these contexts is really what NovaNet is about.
Yeah, I think thinking about NovaNet as a peer-to-peer project and network like IPFS, as it's inspired by in part with the technology, is a good way to think about it as well. But then having the incentive layer come from not a new blockchain, but an existing one, Ethereum, having a token as well. And I think that's a good way to think about it. So not being a separate, again, blockchain with a separate block history of transactions or even a history of proofs per se, but also in certain cases adopting economic or crypto economic security where it's kind of warranted, where we want the provers to be sure to have certain quality and be there when the network needs them.
Yeah, it gets back to the first question with the yin and yang. Like if we're using zero knowledge proofs to do a lot of this stuff, we can just use it in our own system. So it's there's a layer of the peer-to-peer portion that does use ZKPs for making sure there's no trust assumptions. And there's also the bigger layer, which is the L1, which is controlling the actual token itself. And you can post the proof to the L1. That's when the actual tokens get dispersed among provers. But it's a pretty cool system, and we're looking forward to making it open source and releasing it. The ZK VM that we mentioned is actually, we're going to do soft launch for that in August, so anyone can try it. If anyone does want to try it now, we actually do give the binary out. Like, so if you have a WASM code or a RISC-V code, you can just run it directly through the binary to see like speed and portability and other things like that if you want to. But the open source work for the ZK VM itself will be in August. And then from there, hopefully working with a bunch of cool partners to get into production readiness.
Well, you mentioned one thing earlier, that the verifiers are sort of like agnostic towards whether the proofs are posted to blockchains or Web2 servers or sort of anywhere else. What's your expectation in terms of like the early use cases? Do you think most of the proofs will end up getting posted to Web2 servers? Do you feel like most of the proofs will end up getting posted to Web3 use cases and blockchains? Or curious how you see it.
There has been actually a few monolithic like ZKP proving networks that try to force people to use their provers and their verifiers in the past. So we've kind of were able to see those use cases and say, hey, that's not great for all use cases. So there's a few different like monolithic L1s that are just focused on ZK. You have to use their verifiers and their blockchain and their token and potentially even their own like specialized programming language to do it. And we really like want to do the complete opposite thing. Like you use whatever programming language you want, compile it down to WASM or some other format, and then we'll just run it. Like it should be as nimble and fast as possible. So really what I expect is that a bunch of people will be posting to their own ecosystems. So if you're an AVAX project, you'll be doing that. Solana, you'll be doing that. I think that gives you the freedom to go where your users are. We don't want to be opinionated at that at all. Like we don't care. You can post it wherever. But even for Web 2 coming into our space, like there's Web 2 companies that want to use ZKPs. And if they look at these monolithic stacks, they say, hey, I don't want to use like whatever token just to do my one Web 2 thing. Like I'd rather use something that can post my data directly to a Web 2 server. So I think we have a bigger net in terms of the possible use cases because we are not opinionated about verifiers.
Yeah, 100%. I think that's most of the kind of meat of the questions that we had for you guys today. There's a quick lightning round we want to do at the end here. So I think, either of you, both of you can chime in, but just looking to give you like a word or phrase and hear a phrase or a couple sentences back just on what comes to mind when I say these prompts. So the first one is, looking at both of your Twitters, it seems like you guys are both Internet Computer or Dfinity fans or, are interested by what they're doing. So just curious, like, what the relation is there, what you like about the project, that kind of thing.
Yeah, we actually both started on a grant from Dfinity to do a no-code solution that was like front-end UI. I think it's interesting because both Houman and I applied for the grant at the same time, and we didn't know each other then. And they're like, hey, there's this other like guy who wants to do kind of the same thing as you. And that's actually how we met very early on. I think the project itself, like the Internet Computer, is a great technology. It has very different trust assumptions and very different performance attributes to any other L1 I know. I still see it as a very good way to doing like verification for zero knowledge proofs. So for example, right now, what people do is like they take a new proving system and they have to get it onto Ethereum. And for that to work, like you have to do a bunch of specialized things to make it small enough to get onto Ethereum. I've always been an advocate for like just ZKP just to go onto some other layer. And people are doing that with eigenlayer now too. So it could be like ICP or eigenlayer where you can have a different form of security, but also get verification without doing like all the specialized work just to get it onto Ethereum. So I definitely see like super valid use cases for ICP. And I think proof of verification is definitely one of them, but there's a few others who like data storage and things like that.
Yeah, I think it's a unique and exciting and a pretty ambitious project out there. So we'll see how, the future develops. There's a lot of exciting and ambitious projects. I've been digging deeper into Solana and AVAX and also obviously keeping up with developments in Ethereum. So that's really cool. And plus just so many other micro and macro things going on in crypto. But ICP is certainly, I think, something to keep an eye on.
Cool. So now to talk about DePIN, what do you all think of the acronym of the sector of crypto that's emerged, pretty in a pretty relevant way this cycle? Just, first impressions on DePIN, as an acronym and as a sector of crypto.
I like DePIN as an acronym, and I think it very much could be one of the killer use cases for crypto going forward.
The first time I heard it, I had no idea what it was about. But I actually like even being a tech person, I think it's really like funny. And my same brother I was mentioning earlier told me about NFTs the first time. I'm like, what the hell is that? Like, that doesn't sound cool. He actually tried to convince me to build like a marketplace because at the time there was no NFT marketplaces. I'm like, oh, but we always attach these like 3-letter acronyms, and ZKP is another one. They have sometimes very different meanings than what they actually like are used for. But the first time I heard DePIN, I'm like, what is this? And actually diving in, it's actually extremely exciting stuff in general. Every time I hear about a use case that people are diving into technically, it's always really, really cool to hear about what people are doing in the DePIN space.
We agree. Yeah, I mean, especially this cycle, the proliferation of just so many different projects launching in different kind of like real world sectors, whether it's energy or telecom or anything else, has just been really, really cool to see. So yeah, glad you guys are excited about DePIN as well. Curious, what's kind of the most interesting use case for ZK you've ever seen? So I think a lot of the classic examples are like, prove that you have a certain bank account without revealing the actual balance, or prove your age without revealing your actual age, prove you're over a certain age. But yeah, curious, most interesting use cases for ZK you guys have seen kind of out in the field, people using day to day.
I don't know if they're using it day to day, but there's a few different ones. Like ZK voting is always one that's high in the societal issue list. Like if we had ZK voting, it would solve a lot of problems. I think actually was in Mexico not too long ago. I actually was thinking about using it. There was a news article about it. There's a lot of like high ticket items like that, but just like pure technical nerdiness, I would say like ZK AI is something I really like to be the Kool-Aid man, smashing through with ZK ML into a DePIN conversation. But you can actually mix ZK also with artificial intelligence to have verifiable AI. And it'd be cool to have like private models, like you imagine a trading bot trading, or private gaming models doing games, or do private inputs. Like right now, when you type your input into ChatGPT, it's taking off your data and it's using that over and over again for other people. So there's like no privacy right now. I think as the political situation with AI becomes more and more prevalent, I think verifiability in that space will become more important. So from like a pure tech perspective, that's what I think is super interesting as well.
Houman, what about you? Any interesting ZK use cases?
In terms of use cases, I think that bringing ZK into the law and regulation has a lot of potential, untapped, of course, so far. But whether you signed a contract without revealing the contents, complied with regulations, of course, in the KYC, anti-money laundering sense, so that's a proof of identity, but also even bringing in a courtroom evidence and proof in the legal sense using ZKPs. Some people are talking about already in kind of academic legal literature. But that also includes, there's a really exciting article about ZK and the law written by, I think, one of the original authors of the original ZKP paper. I forget their name, back in the 80s. So I think people see the potential for this tech. It's just always been so expensive and off the radar and theoretical until now. And that I think we'll see, and we're trying to position ourselves for these kind of Web 2.5 use cases.
There's actually a really cool post of Satoshi on one of the old forums talking about zero knowledge proofs. And he's basically like, if this stuff was only fast enough and cheap enough, like we could totally use that right now for privacy. And then Zcash guys, I think, read that and maybe built Zcash from there. But it's funny because I spoke to my brother not too long ago about like what they did for privacy back then. And it was basically you just minted new coins. Like that was it. Like, why would you use any old coin that other people were using? Just make your own new ones. So I think like since then, the 10 years that we've been, or whatever, 14 years, not exactly sure, it's been like game changing how the stuff has changed in such a short time.
100%. Yeah, I think the pace of technology improvement just continues to accelerate. And now with AI being so prevalent, like I think the rate of change goes up even faster. So super exciting. Last lightning round question. I want you guys to put on your macro, maybe trader hats for a second here. Like what inning do you think we're at in this cycle out of like a 9-inning baseball game? Because I tweeted the other day, like kind of like the current celeb coin, scam, meme coin meta that's going on, which is obviously probably a net negative for this space in terms of B-list, A-list celebrities launching meme coins, having a ton of the supply, dumping on their fans. Like that feels very top-ish. Like that was going on at the end of last cycle. And it feels like, you know, we could go a lot higher in terms of like the lengthening duration of this cycle and asset prices being higher, but it also like we are having this kind of celeb scam coin meta happen right now. So I'm curious just like how far through this cycle you guys think we are in terms of which inning out of 9.
I think right now it's summertime and therefore like it's going to be slower than usual. I think we're so near the last ATH. So it's still like extraordinarily bullish. Like people are short-sighted. So they see something go down and like, oh, we all have to bail out. But really, if you think about it in a longer term perspective, like crypto has been going up basically the entire time. So if you think of like Warren Buffett or those guys, they invest in like blue chip stocks very early and they just hold them for a long amount of time. So it's a very simple strategy. Like if you're in crypto and just like invest it the entire time and not try to time the market, you'd be good. So in general, super bullish. I think we're going to basically continue the trend that we've had over the last, since crypto's inception, essentially.
Sweet. Houman, what about you?
Yeah, I was going to say early third inning also in this cycle. We still have Fed rate cuts to come at the Ethereum ETF, but probably more importantly, just a lot of innovation from a lot of teams and a lot of protocols, ICP, AVAX, Solana, throughout DePIN. I mean, people are pushing really good stuff, in my opinion. That's going to have relevance for all of those protocols and all the exciting multi-chain interoperability, whether it's Wormhole or Layer 0. Account abstraction, just everyone's trying to make things better, faster, easier for users. I don't see that stopping. And I think, 12 months from now, things will look very different in mostly better ways. And I think the celeb meme coin dumping, maybe that was the top of the last cycle, but it's just maybe so much easier to launch your own coin and pump and dump that doesn't reveal too much about where we are.
Yeah. No, I think great commentary from both of you. I appreciate that. Sometimes founders like don't want to put on the macro hat, right? They just want to talk about what they're building, but it's cool to zoom out and think about crypto kind of as an industry and think about where we're at in the cycle. So yeah, appreciate your thoughts there. I think with that, we're pretty much wrapped up. Sal, is there anything else you want to ask or anything else you guys want to kind of comment on or riff about?
No, nothing. Oh, well, I want to make sure that any DePIN founders listening can know where to find you guys and have some ideas for when the testnet or mainnet goes live in later this summer and get some ideas for how to get the proofs into production.
NovaNet.xyz, and there's actually a newly created Telegram group where we're kind of collecting people together with more general questions. Any technical people, definitely dive in, have questions there. It's very direct, like Houman and I are both in it, and a few other engineers as well. So hopefully running up to this testnet, we'll keep adding people onto there and have more direct conversations with developers and DePIN. CTO is basically looking to use this type of tech.
Awesome. We'll add the link to the description. Thank you guys for making time to join us.
Yeah,
thanks so much, guys. Thanks for listening to the Proof of Coverage podcast. We'll be posting one new episode a week on Mondays, interviewing the best DePIN and crypto founders out there. If you like this episode, please follow us on Twitter or X at CoverageProved or on any major podcasting platform. Thank you.